All right, we're going to solve this quadratic equation by graphing. So make sure you've written down the problem, have a graph ready, and I'll have tape up on my desk for you to tape it in your notes. So again, we are trying to solve this equation. So we're trying to find the value of x that makes this equal to 0, which is the same thing as the x-intercepts to that quadratic as a function. So we're actually trying to find the x-intercepts of that quadratic. Now that's true as long as it's set equal to 0. If it wasn't set equal to 0, we're not talking about x-intercepts anymore. But since it's set equal to 0, it's in standard form here, we are looking for x-intercepts of this quadratic. So that's all we have to do is graph this quadratic. So we learned some easier ways to graph quadratics than just making a table. So we're going to start out by finding the vertex. So we got x equals negative b over 2a. And in our case, a is equal to 1, because we're talking about standard form still up here. B is equal to 6. So again, if it wasn't equal to 0, we couldn't even identify a, b, and c. Anywho, so x equals negative of 6 over 2 times 1, which equals negative 6 over 2, which is equal to negative 3. Also, feel free to pause this video at any time to catch up with me. So that is the x value of the vertex. So x equals negative 3. Now let's find the y value of the vertex. So we're going to plug in negative 3 for x into our function, because remember, we're actually graphing that function right now. And we're going to find the y that goes with that x. So negative 3 squared plus 6 times negative 3 plus 8. 9 minus 18 plus 8. 9 minus 18 is negative 9 plus 8 is negative 1. It's a little sloppy. Sorry about that. And then, so that is our vertex, is negative 3, negative 1. So we also know that, and make sure you're writing this down, that that's your vertex. And then, so we also know that our axis of symmetry is whatever the x value of the vertex is. So that's our axis of symmetry, x equal to negative 3. So we are going to graph that here. I'm going to graph the axis of symmetry first. So I zoomed in a little. So we have x equal to negative 3. Whoops. So there's our axis of symmetry. And then our vertex is at negative 3, negative 1. So there's our 1 point to start out with. Now we know, remember that when we first started graphing quadratics, we did from negative 3 to 3, but now we know that, because that would almost guarantee that we'd be the center of the parabola, but now we know that the center of our parabola is whatever the center is, which is the axis of symmetry. So instead of plugging in negative 3 to 3, think of this as your new origin. So plug points in around your vertex, x value. So since it's negative 3, we're going to plug in 2 above and 2 below. So negative 2, negative 1, and then 2 below, negative 4, negative 5. And actually, if you remember our twin points, we actually only need to do 1/2 of that, because we know that the values are going to repeat for x values that have the same distance from our axis of symmetry. So we're going to do negative 3, negative 2, negative 1, negative 4, negative 5. So we know negative 3's output is negative 1. If you plug in negative 2, here's what you get. Plus 6 times negative 2 plus 8. So that's positive 4 minus 12 plus 8. 4 minus 12 is negative 8. Negative 8 plus 8 is 0. Oh, so that's 0, which actually means that there's one of our roots right there. That's 0. So we have 0 for that one. And then we're also going, and that means we also have 0 for its twin point, which is negative 4. So we know it's also negative 4, 0. And then we need to find one more, so we're going to find f of negative 1, which is that there. So we got 1 minus 6 plus 8. So we have negative 1 minus 6 is negative 5 plus 8 is positive 3. So that tells us that our outputs for our other two twin points are 3. So we have our list of points, so we can go back to our graph and graph those. So I'm going to zoom in here. So for our graph, we had 0, we had negative 2, 0, negative 4, 0, and then 3, negative 1, 3, negative 5, 3. And then that was our parabola. We can draw it, and now we can identify our x-intercepts, which again we could have done before even graphing it, but they're right here. So since they turned out to be nice, meaning the roots were whole numbers, well, integers, so negative 2 and negative 4, then we really didn't need the graph. But there's going to be some times where you'll just have to estimate it. But for this one, since our graph crosses the x-axis at negative 2 and negative 4, those are our x-intercepts or our roots. And we also know that from our table, which shows that negative 2 has an output of 0 and negative 4 has an output of 0. So that means for my original equation, when I plug in negative 4 or negative 2 into this equation, I will get 0. And that's the definition of solving an equation, finding the value for the variable that makes this a true statement. So that'd be negative 2 and negative 4. So that is our final answer for this one.